Hi, welcome to this lesson on stacks. So, what is a stack? A stack is basically an ordered group of homogeneous items of elements. Basically, what it's saying is that a stack contains elements of the same data type or of the same nature. So, if it's numbers, it contains numbers within the same data type, whether it's int, double, or long. If it's a string, they are all strings. So the unique thing about stacks, or the different thing about stacks compared to queues and everything else, is that elements are added and removed from the top of the stack. So every element is added from the top, unlike a queue where elements are added from the back and removed from the top. But with stacks, elements are added or removed from the top. So with stacks now, that means whenever you add an element, if you add 4 elements, when you're now removing them, since they are also being removed from the top, from where they came from, the element that's going to be removed first is the element that is at the top. So basically, stacks use the last in, first out principle. So as you add stacks, for example, this diagram here, there are 1, 2, 3, 4, 5 elements. If you add one, they become, if you push, so pushing in stacks is adding an element, okay? So when you push, if you perform a push operation, or if you add something, you're performing a push operation, and that means you've added an element into the stack. And then a pop operation is where you are removing an element from the stack, but you don't just remove any element, you remove the element that is at the top. And since, if you look at this diagram, when we did our push, the element at the top, the first element to be put in was A, followed by B, by C, by D, by E. So that means E is now at the top. So if we are now popping, which is removing an element, we remove the one at the top. So the first one to be removed will be E and not A. Okay. So if it were a queue, the first element to be removed would have been an A, because queues use first in, first out. But in stacks, we use last in, first out. So the last element to be added was E. So we're going to pop that one out. And then the first element to be added was A. So we'll pop that one last. So what kind of operations can you perform on stacks? So the kind of operations that you perform on stacks is you can clear the stack and make it empty. You can create a function, make empty, to clear the stack. You can check whether the stack is empty or not. You can check whether the stack is full. You can also then push, which is add a new item into the stack, or you can pop, which is to remove the topmost element from the stack. But as you create your stack, there are certain things that you need to first declare, initialize, or instantiate as you create that stack. So one of those things is the maximum number of items that the stack can actually take. So you need to define and clearly state the number of maximum items that the stack takes. So in this case, you could define a variable called max items, or that contains the number of the limit of the number of items that stack can take. Then you also need to define the data type of the elements in the stack. So if your stack is going to take integers, then we know that that stack will only have integers. If it's going to take double, to have double. If it's just going to take strings, it will have strings. So this is an example of a stack interface. So a stack interface is just showing the methods that can be used as part of operations on a stack. So you can actually have a method like this one, public void push, where you're adding an element, public void pop, where you're removing an element, then public object top. Here you're actually looking at what is the top object. So you just want to retrieve the value of the top object. Then with this one, public boolean is empty. You're checking whether the stack is empty or not. And then public void clear, you can actually clear or delete all the elements in the stack. So what you now need to do is to come up with algorithms or operations or programs that allow you to implement these methods. That way you now have all the operations that you can do on a stack. So what are some of the applications of stacks? So a stack, since it has got a last in, first out operation, it can be used to implement undo functions. So when you perform an undo function, it will first remove or edit the last operation to be done. So if you typed a wrong letter, it will first remove the last letter that you added, and it does not clear the first things. So it can be used for undo of operations, backtracing in games or in applications, or even system rollbacks. So if you've got an update that failed whilst you're updating your system will just perform an update rollback using a stack application by removing the last application, the last operation first, and going backwards until it gets to the first one, and it removes all of them. So this is an example of how a stack works. So initially we've got nothing in our stack. Then we push 2, that means we add 2. So 2 is now at the top of the stack. Then we push 3 into the stack. Now when we push 3 into the stack, it means 3 is now at the top and 2 is now below 3. Then we also push 5, which means 5 is now at the top and 3 and 2 are below 5. Then when you pop X, it doesn't matter what X is. X could be any value as long as it is the topmost value. And the topmost value here is 5. So when you remove 5, the next value that now becomes at the top is 3. So last in was 5, but it was first out when we code a pop function. Then the next pop operation will remove 3, which is now at the top, and 2 will now be at the top. Then if we do a push operation, then we have 10 at the top and 2 next to 10, and 5 has already been removed. So that's basically how stacks work. We'll look at some code implementations of stacks so that we can have an appreciation of how we can actually implement them practically. Thank you for listening.